yeah.
Thank you. Excellent. All right, so the question is, why do you have a domino? Why do you have a domino? So my family, we play a game called 42. We play with dominoes. It's kind of like spades with cards. Anybody ever played spades before with cards? Okay, so in my family, we play 42. It's a domino game. And part of the domino game has this thing called sevens. Sevens, okay? Awesome. I don't think anybody's paying attention to what's going on right now.
I have spades as cards.
Sevens. All right, so I want you to tell me the number on your domino, and then I'm going to tell you a number. Are you ready? Oh, you have 7. All right, so let's go first with Camilla right here. What's your number? Well, no, count them. What's your number?
8.
Is it 8?
9.
9. All right. So Camilla's number is 9. I'm going to tell her 2. Maisie, what's your number?
4.
4. I'm going to tell you 3. Mason, what's your number?
4.
4. Also 3. Shub, what's your number?
8.
8. 1. Wyatt?
8.
8. Also 1. Britton, you got a domino?
Yes.
What's your number?
5.
5? 2. Duncan, what's your number?
2.
2. 5. Yamaleth, what's your number? 3. 4. Abby, what's your number? 9. 2. And Neko, what's your number? 12. 5. Marcus, you got a number? 6. 1. Zaylee? 8. 1. Joseph? 10. 3. Dana? 5. 2. Are y'all getting this yet? Yeah? Okay, keep going. Sophia, what you got? 10. What's her number? 3. Good. 7. Oh, what's her number?
0.
There we are. Benedict, what's your number? 6.
1.
Last one. Okay, so the name of the game is sevens. By the end of the game, you've played all of your dominoes, and each hand, you're trying to have the number closest to 7. The number closest to 7. So if I have an 8, how far away from 7 am I? 1. Notice that if the person had a 6, so I'm looking right here in our numbers. If the person had a 6, I told them their number was 1. If the person had an 8, their number was also 1. So the game of sevens doesn't care whether the number was above or below 7. It just wants to know what's the distance from 7. What's the distance from 7? Okay? So what are we talking about today? Have you figured it out yet? Anybody ever heard of this in math? Distance. Sure. Distance. Okay? So at this point, we don't need the dominoes anymore. I'm going to have you pass this tin around, and you can just put them back. Stack them neatly for my next class, sure. Okay, so this is going to be 2.6, part 4. Hey, just focus. 2.6, part 4. And the types of equations we're solving today solve an absolute value equation. Absolute value equation. Okay. So we're going to start off by saying this. A number's absolute value. A number's absolute value is its, no apostrophe there, is its distance from 0. A number's absolute value is its distance from 0. So the game that we just played with the dominoes is called 7, so it would be number's distance from 7. But absolute value, which is what we're talking about today, is a number's distance from 0, from the number 0. Okay? So distance, I also teach physics, you guys know that, and calculus. In distance, we talk about a number's distance being its mileage. right? Or if a car has traveled a certain distance, it doesn't care which way I went. It just accumulates miles, okay? That's the difference in distance and displacement. In displacement, that is how far is the object from where it started. Okay, everybody hear me? So if I start in Pampa and I drive to Amarillo, what's the distance covered there? 60 miles-ish. Okay, distance would be 60 miles. Let's then say I turn around and come back home. What's the displacement? Displacement is a distance away from where I started. 0. Displacement in that case would be 0, but distance would be 120. Because distance doesn't care which direction I went. It's just counting up miles, right? Absolute value measures distance. It measures how far a number is from 0. It does not care in what direction. Are you with me? Okay. So let's put a number line on your paper. Put a number line and let's put 0 right in the middle. Put 0 right in the middle. And let's let this be positive 3. Positive 3.
-2.
Okay. How far away, how many hops from 0 is positive 3? 3 hops, right? If I go 1, it's okay. 2, 3 hops, right? So 3 is located 3 away from 0. Would you agree with that? How far away is -3? Also 3. Because we're measuring distance. And I don't care in what direction. I'm saying 3 hops to get to 0 from -3. Would you agree with that? Okay. So the absolute value of -3 is 3. The absolute value. So these vertical lines, they mean a number's absolute value. How far away is that number from 0? So the absolute value of -3 is 3. The absolute value of positive 3 is, how far is 3 from 0? Is 3. Okay. Is that making sense?
Not really.
How far is the number from 0? That's what the absolute value tells you. So let's practice a couple. If I have the absolute value of -19, how far is -19 from 0? 19 away. You see? How far is 1 from 0?
1.
1. So the positives are real easy, right?
Kind of.
If I put in here the absolute value of x is 15. What's x? Oh, x could be positive 15, or x could have been -15, because I know the absolute value of -15 would also have been 15. We kind of understanding, conceptually? Okay. So we're going to be looking at equations that have these absolute value businesses on there. Okay. Couple of rules. Absolute value of a number is always positive because it's measuring distance. And distance doesn't care if it's positive or negative. It's always positive. Just like we said, I go to Amarillo, 60 miles. I come back home, also 60 miles. That's 120 miles altogether. It doesn't care if I'm going forward and then backward. Doesn't matter. You following that? Okay. So the absolute value of a number should always be positive. There is no case where I'm going to take the absolute value and get a negative number. That never, ever happens. Still no. You're still covering miles, right? So wouldn't that be great if we could take miles off of our odometer, right? If we throw it in reverse and we just back her up, right? It doesn't work. You're still accumulating distance. Right? I mean, you could really make a Toyota last a lifetime, right? If I could drive it backwards and help it out a little bit. Okay, so listen. This is never going to happen. I am never going to have a case where the absolute value of my number is negative. That does not exist. The reason for that is absolute value measures distance, and distance is always positive in any direction. Okay, so let's actually take some notes on how to solve these. How to solve an absolute value equation. How to solve an absolute value equation. Number one, isolate the absolute value expression. You're going to get that piece by itself. Just like we did when we had radical equations and we wanted to isolate the radical. We want to isolate the absolute value expression. You're going to know it's the absolute value part because it's going to have these vertical bars. A lot of times what we have in there is some linear something, ax plus b. We want to get that piece by itself.
The AX plus B?
Well, with the absolute value bars. We want only that part on one side of equals, and we want everything else on the other side.
Like part 2.
Mm-hmm. Number two, if C is greater than 0, if C is greater than 0, so C is going to be this part up here, absolute value of AX plus B equals C. If that number C is greater than 0, we're going to split into a positive and negative arguments. Okay. So this goes back to the fact that earlier I said, hey, let's say the absolute value of x is 15. And y'all said, okay, cool. That means x could be positive 15 and x could have been negative 15, right? Y'all have already done that today. You recognize exactly what to do with that. This happens if C is greater than 0. If C is less than 0, that means that I have my absolute value stuff equals a negative number. And I just told you that wouldn't work. So what's your answer?
No solution.
Yeah, no solution. No solution.
Could it be imaginary?
Nope. Nope, you're never going to get a negative number of an absolute value. Not ever going to happen. And the other thing that you might get is that what if it equals 0? Then I don't have to split it into positive and negative option. I just set my argument equal to 0. Because 0 is not positive or negative. It's just 0. Okay. And then the last thing here, after you do this splitting it up, is solve. Solve each argument for x. Solve each argument for x. Okay. Okay. Couple of things to think about. Okay. Whoa. Sorry.
That's
Sorry.
the only problem with the video.
Huh?
That's the only problem with the video.
But you got a pause button on the video.
Yeah, but I mean, like when you're in class.
You know, I've got a pause button during class.
Oh. You need a pause button during class?
Yeah.
Sorry.
Or back button.
I just really get excited about teaching this.
I just didn't know about it.
Are y'all ready, y'all?
Yeah, so you said if we can't split it, it's no resolution.
No, so if it's equal to 0, then you're only going to have one solution because you're going to set your argument equal to 0 and solve for x. If the argument, or if it's greater than 0, you're going to consider both the positive and the negative option. If it is less than 0, C, the number C on that side, less than 0 would be negative. There's no solution for that because the absolute value cannot equal a negative number. Okay? So let's look at those 3 cases. These are the rules. So we're talking about this situation here. The absolute value of AX plus B equals C. If C is less than 0, that's going to be a negative number. There is no solution. No solution. Can't happen. If C equals 0, then you just take your argument and you set it equal to 0 and solve. There's not a positive or negative option. It's just one situation there. And you're going to get one solution. If C happens to be greater than 0, then you're going to have two solutions. And that's when you're going to split that argument. You're going to have AX plus B equals greater than 0 situation and AX plus B equals something negative.
Wait, did you write like negative number under the C first one?
Yeah, that's a negative number under the first C, because C would be less than 0. Okay. One more thing I want to caution you against. Okay. If I have a number outside, let's let it be negative 4, outside of the absolute value of 2x plus 3 equals 8. Okay? Doesn't have to be negative. But either way, this cannot work. You cannot distribute the 4. Okay? These are not parentheses. The absolute value brackets are not parentheses, and you are not allowed to distribute into them, right? So instead, you would have to divide both sides by that negative 4. Everybody hearing me on that? If it's just a negative in front, instead of like let it not be a negative 4, let it just be a negative number right here. Divide by the negative. You cannot distribute through those absolute value bars.
How come I can divide but I can't multiply?
So you can divide by that negative 1, right? You can divide both sides. You just can't push into the bars. They are their own thing. It'd be like trying to push into a radical situation. You can't do that. Does that make sense? This acts the same way. They're not parentheses. But the temptation is there because there's no roof. There's no reason I can't go over the top into there. You cannot do that. Good? Okay, so let's do. We have one example. This is, we got one example and to try it. This is example 8, and it says solve the following. Absolute value equations. Solve the following absolute value equations. So for part A, the equation says the absolute value of 6x plus 4 equals 8. The absolute value of 6x plus 4 equals 8. Okay, so step 1, isolate the absolute value. Is that already done?
Yes.
Is C greater than, equal to, or less than 0? Greater than 0. So we're going to split our argument into a positive option where I just keep it exactly like it looks right now. That could have been 6x plus 4 equal to 8. And we're going to solve for x. So what am I going to do first? Subtract the 4. 6x equals 4. And then what? Divide by 6. X is equal to, reduce it. 2/3, good. So that's option A. That's positive. I just keep the argument exactly like it looks, and I set it equal to 8, and I solve.
-4.
Okay. The other option here is, what if the stuff inside had been negative? And I would still get 8 as the absolute value. So we have to consider the negative option. We say, hey, I might have had negative 6x plus 4 equal to 8. You seeing what I'm saying?
Mm-hmm.
Earlier.
If there's an 8, I mean a negative on the...
Now I'm outside of the absolute value.
Oh, okay.
I've split the absolute value thingy, and I'm not dealing with that anymore. I understand what it meant, and I've busted it out into 2 pieces. So now we've got a negative. You could distribute it, or we could divide by it on both sides. And now I have 6x plus 4 equals -8. So let's look at what just happened. What are we saying here? we're saying, hey, the stuff inside here could have made a positive 8, or the stuff inside here could have made a negative 8. Either way, its absolute value was 8. Do you see what we're doing? We're considering that both options could have happened in order that their absolute value was 8. So you're going to subtract a 4.
12.
6x is negative 12.
12 over 6 is 2.
Yeah. So our other option here is x equals negative 2.
That's easy.
It's not bad, right?
Is that like the homework or what?
Yeah. Let's do some more. Okay. Let's do a couple of more. Here's part B. There are 4 on the example. 4 different options. So part B, it says the absolute value of 3x plus 4 is equal to negative 9.
Oh, wait. No.
No solution. And you're done. No solution. And the reason for that is I am never, ever going to have a situation where the absolute value of a number is negative. No solution. Not going to happen. Wish they were all like that, huh? Ready for number C? Or letter C? Okay, this one says the absolute value of 3x minus 5 minus 4 is 6.
Divided minus 4.
Not divide it, add it. Add 4 to both sides. So we're just trying to get that absolute value piece by itself. So now I have 3x minus 5 equals 10. That number's greater than 0. So I have to consider the fact that 3x minus 5 was 10. Or 3x minus 5 could have equaled what? Negative 10. Such that their argument came out as positive 10. Right? So that stuff in there could have been 10 or it could have been negative 10. So that my absolute value came out as 10. Do y'all understand how we did that? Now you solve it. Yeah. Solve both. So 3x is 15. Yep, I get x equals 5 on the first one.
X equals 5. Negative 5 thirds.
On the second one, 3x equals negative 5. Dividing by 3, x equals negative 5 thirds. I agree with you. Questions? No? One more? Here's the other kind, letter D. We have the absolute value of negative 5x plus 10 is equal to 0. Right. So this case is where C equals 0. I could split it. I could say negative 5x plus 10 equals positive 0, and negative 5x plus 10 equals negative 0. And that would be just like the one we just did. But 0's 0. It's neither positive nor negative. So all of this business is pretty much not necessary at all. All I have to do is say, hey, that argument, negative 5x plus 10, gave me 0. So solve for x.
How do you solve for x just like that? Just
Subtract 10 from both sides. Negative 5x equals negative 10. X is positive 2. X is positive 2. I have a try it here. Do we need it?
I don't think so.
Don't? Okay.
We're done.
Pretty good. So I put 4 of these on your test. I tried to pad your test a little bit. Okay, any questions at all? No?
On part 1, 2, and 3.
Well,